Hi students, today we're going to do 13.2, which is the ellipse and the hyperbola. The formulas are not too much different. The equations are not too much different than the equations for the circle. It's just some slight modifications, and we'll go over them with the PowerPoint presentation. So let's take a look. All right, 13.2, the ellipse and hyperbola. So an ellipse is just like a stretched circle. Here's a graph, x squared plus y squared equals 4 squared, or 16. And that is the graph of a circle that centers at 0, 0, and has a radius of 4. If we took that equation and divided both sides by the 4 squared, you see that we'd get x squared over 4 squared plus y squared over 4 squared equals 1. So if we wanted to set it equal to 1, we can kind of think about that 4 squared as the radius in the x direction and the radius in the y direction. Okay, but what if we went from that equation where we've divided by the 4 squared, and what if it wasn't divided by 4 squared for the x and for the y? What if the x was divided by something different than what the y was being divided by? If that happens, then it's going to change the radius in our x direction and our y direction. So over here in this blue, you see we've got x squared over 2 squared and y squared over 5 squared is equal to 1. So what that did is we've got a different equation here. Now our radius in the x direction is 2, and our radius in the y direction is 5. And you can see that graph in blue, how that distorted the circle, and that's what's called an ellipse. So this guy in blue is an ellipse. Its equation is very similar to a circle, except when we write it in standard form, we set it equal to 1 so that we can see the radius in the y direction and the radius in the x direction, because those are going to be different. You can take a second and plug in some of the points there to make sure they work for you. So that point at the very top, x is 0, y is 5. Well, when x is 0, that first term, x squared over 2 squared, goes to 0. When y is 5, we get 5 squared over 5 squared is equal to 1. So we know that's a solution there. Same thing when y is 0 and x is either 2 or negative 2, our equation still equals 1. Okay. So yeah, that denominator for the x, take the square root of that, and that's the radius in the x direction. The denominator for the y is the radius in the y direction. So it's pretty intuitive here. What can make it a little complicated is you have to keep in mind the different forms that this equation might be presented to you in. So in this case, we've got 25x squared plus 4y squared equals 100. When we look at this, we're going to say, I know this is not a parabola because the x and y are squared. Okay. It could be a circle or it could be an ellipse. So the best way to see is to set it equal to 1 by dividing by that, that constant term. So we're going to divide both sides by 100, and that will set it equal to 1. So when we divide both sides by 100, 25 over 100 simplifies to 1 over 4. 4 over 100 simplifies to 1 over 25. So we divided both sides by the constant term, gets us set equal to 1. And now we can see the radius in the x direction is a 2. The radius in the y direction is a 5. So we know we have an ellipse because the radiuses are different. So it's not a circle, it's going to be an ellipse. And keep in mind, one of the biggest mistakes I see is that people think the radius is 4 and 25. But remember, the radiuses are the square root of that number. So the radius is 2 and 5. So let's just take a look at the standard form of an ellipse with the generic equation. So we can move our ellipse around. Its center can be moved anywhere around the plane. The center is going to be HK. Just like before, that number right next to H, or that number right next to X, the opposite of that is the X coordinate of the center. The number right next to the Y, the opposite of that is the Y coordinate of the center. Okay. Now, whatever number the X is being divided by is going to be the radius in the X direction. Whatever number the Y is being divided by is going to be the radius in the Y direction. Obviously, you have to square root those two guys. Okay. So take a look over here at the standard form of an ellipse. We're always going to set it equal to 1. In order to do that, you divide by whatever that coefficient is. And then the center is our HK, just like before. And the radius in the X direction is the square root of the guy below X. The radius in the Y direction is the square root of the guy below Y. Okay. So you'll find your center, and then you'll find your radius in X on both sides, your radius in Y on the top and the bottom, and then you're just going to form that ellipse. So let's do an example. Here we've got 9 times x plus 1 squared plus 4 times y minus 3 squared equals 36. Okay. We've got that 36 there. We know this is an ellipse because both the x and the y are squared. They're being added. Now it could be a circle or an ellipse with just those two conditions, but the coefficients are different, so it's going to be an ellipse. So we're going to divide by the 36 to figure out what the stretch in the x direction is and what the stretch in the y direction is. So we divide both sides by 36. 9 over 36 simplifies to 1 over 4. 4 over 36 simplifies to 1 over 9. So now we get x plus 1 squared over 4 plus y minus 3 squared over 9 equals 1. So I got that second equation just by dividing everything by my constant term, that 36. Okay. With that, we can see that our center is at -1, +3. Right? It's the opposite of what's next to x and what's next to y. Center is at -1, +3. The radius in the x direction is the number below x square rooted. So the x direction radius is 2. So we give ourselves 2 on either side of the center. And the radius in the y direction is 3 because it's the square root of the number below y. So we give ourselves 3 from the center in the y direction. So that's how you graph the ellipse. Set it equal to 1 by dividing by the coefficient, and then identify the center and identify your radius and move out from the center in the x direction of your radius on both sides and the y direction of your radius on both sides, top and bottom, and then you can form that ellipse. Okay, let's do another one. This one's a little bit tricky, and you might have seen something like this with the circle in your homework, okay? So we've got 100x squared plus y squared equals 25. We recognize that this is an ellipse because x and y are both squared, and they're being added. It's not a circle, though, because the coefficients on x and y are different, so we know they're going to stretch differently. Okay. Since we know it's an ellipse, and even if we didn't, we could do this and figure it out, we're going to divide by the constant term. The constant term is at 25. We divide both sides by 25, and we see that we've got 4x squared plus y squared over 25 equals 1. So this is a little tricky. You see that 25 and you say, okay, the radius in the y direction is the square root of 25. But what is the x term being divided by? It's being multiplied by 4, which means it's being divided by the opposite of 4, which is 1/4. okay? So it's a little tricky to see that. You might be tempted to think that the radius is a 2 because the square root of 4 is 2, but the radius isn't 2, it's actually 1/2, okay? So take a look at that and see how I went from 4x squared is the same thing as x squared divided by 1/4, okay? The opposite of multiplication is division. The opposite of 4 is 1/4. So we double opposite it to get back to the same thing. So multiplication by 4 and division by 1/4 are the same thing. Go ahead and do a fraction division practice if you need to convince yourself of that. So our center is at 0, 0 because HK is 0 and 0. Our radius in the x direction is the square root of 1/4, which ends up being 1/2. And our radius in the y direction is the square root of 25, so it's 5. So take a look at this ellipse. The center's at 0, 0. We move 1/2 in left and right, and we move 5 up and down, and then you just create that ellipse using those 4 points. Okay. If you guys have questions on this, on how I got to the 1/4, go ahead and email me and I can give you another example. All right, that's the ellipse. Now let's do the hyperbola. The hyperbola equation is really just the ellipse equation, but with a negative sign instead of a positive sign. That's the only difference in the equation, is that the hyperbola has a subtraction and not an addition, okay? What that does is it takes our ellipse and it turns it inside out, okay? All the hyperbolas that we're going to do, we're going to center them at 0, 0. So you don't have to worry about any XY shifts, okay? The radius in the x direction is the square root of the number below x, just like with the ellipse. Radius of the y direction is the square root of the number below y, just like the ellipse. Here's what's different. Because we've turned that ellipse inside out, it's going to open outwards. Okay, so it could open up, down, or it could open left, right. It depends which term is being subtracted. If the y is being subtracted, then you're going to open sideways. Okay, let's take a look at the equation to understand why that is. In this first equation called the horizontal ellipse, the y term is being subtracted. Now notice the x, y, a, and b are all squared, so those pieces are always positive numbers, and we have to equal a 1, okay? If we're going to take a positive number and subtract a positive number and get a 1, then that first positive number has to be at least 1 or bigger, okay? So that's why the x values have to be at least the size of a or bigger to have any values that make that equation true. Okay, this thing x squared over a squared has to be at least 1. So x has to be at least the size of a. Any x values that are smaller than a, that's these x values between a and negative a, can't be a solution to this equation. So no x values between a and negative a will make this equation true, because it makes this first term smaller than 1, and you can't subtract something from something smaller than 1 and still get 1, okay? So if y is being subtracted, we're going to open sideways, right? Plug in some values and play with that a little bit to kind of understand why that is. Now just the opposite. If x, now we're going to look at that second equation, the vertical transverse axis. If x is the term being subtracted, if x is the term being subtracted, then we're going to open vertically. And it's for the same reason. So we've got y squared over a squared minus x squared over b squared is equal to 1. all these squared pieces are going to be positive numbers. So we're going to take a positive number, the y term, and subtract another positive number to get a 1. Okay, that means this y over a always has to be exactly 1 bigger than this x over b. Since y over a can't be any smaller than 1, or there's nothing we could subtract from it and still get a 1. Okay, so y squared over a squared has to at least be 1 in order for there to be any possible x's to subtract. So if y squared over a squared is 1, that means that y has to be at least as big as a. So you see that all our y values are the size of a or bigger. So y can be the size of a or bigger, or of course the y can be the size of a or smaller because we're squaring it. So the magnitude just has to be greater. Okay. So if y is being subtracted, we open sideways. If x is being subtracted, we open up and down. And then that green box that you see, we make a box using the a and the b, the numbers below x and the numbers below y, just kind of like we would with an ellipse, but that green box is just to guide the way our parabola opens. So we make the green box, we figure out if we open sideways or up and down, and then we draw these lines that go through the center and the corners of the green box, and that guides the opening of our hyperbola. Those red dotted lines are guided by the green box, and those are the asymptotes of the hyperbola. Okay, so it's really just the stuff in blue that is the actual graph of the hyperbola. The rest of it is all just there to guide how we draw that hyperbola. So let me compare the hyperbola and the ellipse for you. This equation in green is the ellipse, and this equation in purple is the hyperbola. The only difference between the hyperbola and the ellipse is the negative sign. Okay, so x squared over 4 plus y squared over 9 equals 1 is going to give you an ellipse. The x radius is 2, the y radius is 3. When we turn that into a negative sign, it flips that guy inside out, but our x radius is still 2 and our y radius is still 3. We'll just draw that box, put those dotted lines in, and that'll help tell you how your hyperbola opens outward. Because the first two graphs are a different scale, I graphed them together. So that third graph is this circle or this ellipse and this hyperbola graphed together. And you can see how if you took the green thing and flipped it inside out, it becomes that purple guy. Okay, so that's the only difference between the hyperbola and the ellipse is that subtraction sign. All right. So that's the lecture for 13.2. I'm going to make another video that will give you just a couple, just going to demonstrate how to graph those hyperbolas. This should be enough for you to get started, but I imagine the hyperbola is a little tricky, so I'll make a second video where I graph the hyperbolas on my whiteboard just so you can imagine how you're going to do it on paper. Definitely take your time going through this video. I'm going to post the slides as well, so take your time looking at the slides and really understanding what's going on. I mean, we have 6 slides. You want to take 10 minutes to look at each slide and really understand what's going on. Okay, it's very dense material, but it's only 6 slides, right? Okay, good luck. Email me if you have questions.